Hi, I am Nandini and I'll be talking about space-based coral bleaching monitoring over Indian Reef region need for high-resolution SS data. In the presentation, I'll be talking about these mass coral bleaching events whose frequency is already on the rise, and we are able to see some examples coming from the Indian Reef regions right on this slide. Coral bleaching monitoring system that was developed and hosted on Veda's geoportal of SAC, which detected an unusual warming of Lakshadweep seas in summer 2020. We also received a ground confirmation of coral bleaching of Lakshadweep Islands during the same time. And we did a quick comparison of summer 2020 SST conditions with 2016 and 2023 as one of the reference pre and post bleaching years in the 8 years period of the recent past. And what are the general improvisations required in modeling bleaching for warning? If we look into the coral reef regions of India, what we find is that coral reef regions occur as naturally fragmented habitat regions in the Indian Ocean. And these regional settings for all these reefs, like we have Gulf of Kutch and Lakshadweep in Arabian Sea, and Andaman and Nicobar and Gulf of Mannar and Park Bay in Bay of Bengal, they all require independent approaches to study, model, and forecast coral bleaching, because these regions, they are unique in terms of their regional settings, and they don't bleach at the same time, and neither their bleaching intensities remain same for each of the bleaching events. So when we delved into the background studies while building up the models, what we found was that initially with had ISST1 data, because of its long-term availability, that for Lakshadweep, as a case example, the SST, whether it is for the warmest month or for the warmest quarter, is showing a kind of steady rise, as like any other reef regions of India. And what we can see also on the left hand side in the second pane of the graph, that below one, that from 1950 to 1980s, almost for each year, in case of the summer anomalies, negative anomalies were more prevalent, whereas after 1980 this was replaced by kind of positive anomalies, very consistent rise of the positive anomalies. And in that too, what we find is that 1998 and 2010, these 2 years stand out very tall in terms of their SST anomalies, because these were quite well-known bleaching years. And moving from HEDI-SST1 to OI-SST series, when we did the same exercise for Lakshadweep again, yes, this data too picked up 1998, 2010 and 2016 as some of the very major bleaching years for Lakshadweep region. Now, coral bleaching monitoring system, which was customized on Veda's geoportal of SAC, it kind of showed a successive warming of Lakshadweep region in 2020. Right in the time when we were in lockdown due to this COVID pandemic and all, during the same time when we were monitoring this system, that every day with reference to what we are seeing for this Lakshadweep, right from 1st of March to 31st of March, what we could see is that slowly the negative anomalies are translating into positive anomalies to the order of around 0.5 degree Celsius towards 1 degree Celsius in a very quick progression, as compared to its Andaman and Nicobar island counterparts in Bay of Bengal. And once we saw this kind of a signature in the model, then it came to our mind that what's happening at individual reef scale, because this is only a regional model over here for all these regions. And if we look into Lakshadweep reefs as a region, what we find is that this is not only a subset of Arabian Sea. It is a cluster of 16 reefs where we have different reefs with different kind of spatial settings. We have huge submerged banks like Cheriapaniam Reef, which is of 115 square kilometer, and we also do have a very small reef like Biti, which is covering only 6 square kilometer. We have reefs with islands like Androth, which is having an island of 5 square kilometer with an adjacent reef of 14 square kilometer. And we have huge reef like Bitra, where there is a 74 square kilometer reef with a very small island of to the order of 0.14 square kilometer. So it's very important to know that how each of these reefs are responding towards this kind of mass bleaching events in case of this SST anomaly years. And because these islands are like whether their response to this kind of events are same or it's different. So one of our students from IIRS, she delved into this question of looking into the island-wise sea surface temperature conditions for all these years with OISST CDR data, which is available on Google Earth Engine. And what she could find is that out of these past 8 years, coming from 2016 to 2023, 2016, 2020, and 2023, these 3 years stand out as anomalous years as compared to any other years, whether it is 17, 18, 19, or so. And 16, 20, and 2023, in these years, the anomalies have reached for almost for all islands, they have reached to a level of 1.5 degree to 1.9 degrees Celsius. And in case of 2023, in fact, there are some of the islands which are recording anomalies to the order of 2 degrees Celsius and more. And if we look into the residence time of the thermal stress in terms of the DHW conditions, which is a very popular index for measuring the thermal stress intensity over a 12 weeks aggregate period, then we find that in case of 2016, yes, they're for all these 16 islands, they are almost kind of registering a score of more than 12 DHW, or they're crossing 10, and it's almost close to 12. In 2020, again, almost all the islands are consistently reaching up to 12 DHW or so. But in case of 2023, which is this year itself, of course, few of the islands have like crossed DHW mark of 10, and few of them are still like yet to reach that. Specifically, the northern islands and the central islands, a few of them have reached this particular mark of DHW10, which are considered to be as very high values in terms of DHW scores. Now, if we look into just compare these anomaly years in terms of how each of the islands DHW conditions are like if we compare them, what we find is that these central islands are kind of showing a very parallel trend from 2016 and 2020, and these islands right from 6 to 11 specifically, so the islands of Perumalpar, Kadmat, Amini, Bangaram, Agati, and Piti. These central islands are kind of showing a thermal intensity or a stress cluster over here in Lakshadweep, along with, of course, Cheriapanyam, which is the second island. So, during the same time, when as we observed that from our model, we communicated this to our friends from Lakshadweep, and to ask them for looking for that whether there is any kind of mass coral bleaching. And in fact, they confirmed yes, specifically for these reefs, the corals are also bleaching. And in fact, the first photograph that we are seeing here from the Cheriapanyam reef, that is not a coral, that is a giant clam. It's Tridacna maxima, and so it is itself is communicating that it is not only the corals. So this kind of mass coral bleaching events are not confined to only the corals, but also to any kind of marine invertebrates, animals, or organisms which is having any kind of zooxanthellae association. They are going to bleach during this time. So this kind of events are regularly happening in Lakshadweep. And in case of this kind of events, what is very important is that we are able to pick up this kind of island scale variability, because as we have learned that these are very small islands with reefs or submerged banks with them and all. And in this case, of course, one of the very welcoming solution to our problem with OISST data, which is currently at a very coarse resolution of 27 or 28 kilometers, can be to use the reanalyzed coral temp data, which is coming at a 5 kilometer spatial resolution from NOAA's Coral Reef Watch website. And here, of course, we have put two examples of Bangaram and Minicoy Island from Lakshadweep, where we can see that there are subtle variations in terms of either SST or SST anomaly. If we look into the cluster of pixels that each island is hosting. However, even this proves to be not sufficient, and if we look into 100-meter spatial resolution data from Landsat 8, of course, where one of my colleague is showing that he is able to pick up that variability of sea surface temperature in terms of Agati Islands lagoon. So these kind of signals or signatures of SST for reef for picking up this spatial variability for these small islands is very important for these kind of coral bleaching assessment and to take management actions and all. And of course, it will be a welcoming step when SSTs will be kind of matching up this eco-stress kind of spatial resolution, what we are getting for with eco-stress LST nowadays, with reference to this 65 meters or so. So and these are kind of certain improvisations which will always be felt for and required when we try to do this exercise for building up the algorithm for SST based coral bleaching forewarning, their real-time monitoring, and implement that plan for any kind of management actions. So that's it. Thank you.